we are going to be picking up the countdown clock. You see it holding now at T-minus 6 hours and 40 minutes. We're going to be picking up the count in just a few minutes. We reached a standby. Countdown clock will resume right now. So we have the countdown clock moving, as you can see on your screen, at 7:07 a.m. Eastern Time. We got an update on the core stage liquid oxygen loading. They are now in fast fill. Again, the core stage liquid oxygen, the LOX, is now in fast fill. The pump speed for fast fill, about 2.5 times faster than slow fill. Stand by. As we stand by. As you're looking at this view right now, this is engineering camera 814 going through a scan of the core stage tank. If you've been following the operation, and you know that we had some cracks develop in the thermal protection system. That's that spray-on foam. That's a rusty brownish color. And so what this particular engineer is doing right now is taking a close look at the tank, and this will happen throughout the tanking operation. Some cracks were discovered when we got the tank filled during the first launch attempt. Some of the cracks, when the tank gets super chilled, can have a cryopumping, something that's called cryopumping, where air is literally pulled into the crevice, super chilled, frost develops, and then it creates a vapor trail. It can appear like a leak, but it's actually not. They're very familiar with these cracks, especially the engineers going back to the space shuttle program, where the external tank, which had the same thermal protection system, have a lot of familiarity with how it responds when cryogenic temperatures are reached on the inside of the tank. You can see at the bottom there, stand by. At T-minus 6 hours, 34 minutes and counting. Stand by. Getting an update on the liquid hydrogen. The team talking to the NASA test director right now. Once that's complete, we'll have an update, so stand by. 7:15 a.m. Eastern Time here at the Kennedy Space Center in Florida. Got an update on the liquid hydrogen loading. They are in stop flow at the moment. There was a leak detected in the engine cavity. Went up to 8%. That put it in automatic revert for the liquid hydrogen flow. Rocket's in a safe configuration. Looking at the path forward, the team is going to let the area where the leak is coming from, which is a quick disconnect, I'm going to let it warm up. It should take about 30 minutes. So we're going to put them a little behind on the hydrogen timeline. And the hope is that it'll warm up that QD, and once they hit it with cryos again, hoping to reseat that quick disconnect. The leak is in the plate cavity around the quick disconnect, indicating that there is a QD seal leak. This is not the same as last time. Want to note that. Again, not the same QD as the previous hydrogen leak. This one has been tight in 5 previous flows. So the team is working that pre-plan right now, and we'll of course keep you apprised. Just to overview, core stage liquid oxygen is flowing, but the team has reported that they will adjust their pump speed because the core stage liquid oxygen levels are supposed to be kept at a specific proportion to the liquid hydrogen. It's called the aft strut constraint. And it basically says that you can't be above 50% liquid oxygen until they have at least 5% liquid hydrogen in the tank. That is because when super chilled propellants, liquid hydrogen and oxygen, go into this core stage, it can shrink the vehicle very minimally, extremely small, but that affects the struts, which are connected to the solid rocket boosters. It can actually, the movement of the core stage must be in proportion all the way along the vehicle in its connection points at the aft strut. You can see the aft strut if we take a look at the bottom of the engine section. So again, core stage liquid oxygen team saying they're going to slow their pumps a bit. They were in slow fill as of 7 a.m. And there you see a shot of the engine bay there. And the aft struts. You can see those. They are the silver-colored connection points where they are attached to the core stage. They attach the core stage and the solid rocket boosters. You have the solid rocket boosters on either side. They are not affected by temperature, but the core stage is. And so they want that aluminum core stage shrinking at the same rate at the top and the bottom when they load propellants. So again, the liquid hydrogen team in stop flow, working a leak in the engine section. Stay tuned for more updates. This is Artemis Launch Control.